All right, this is your, I don't know, I guess I'll call it express corrections for the RC1 Mini STAAR. And what I expect you to do is follow along with me, whatever I write and notate, I expect you to write and notate. And then I will just check to verify that you have listened to all of the videos on Edpuzzle, and you'll turn in your test, and that'll be your corrections. Okay? All right, so let's get started. Number 1, we have 4 in A. There should be a little plus sign in here. 4 atoms of sodium plus 2 molecules of oxygen gas produce 2 molecules of sodium oxide. How many sodium atoms are produced in 1 sodium oxide molecule? Okay, so first of all, be careful. You have 2 sodium oxide molecules, but the question asks about how many sodium atoms are in 1. So a single sodium oxide atom looks like this. I took the coefficient off. There is a subscript of 2 on the sodium, so I know that there are 2 atoms of sodium in 1 molecule of sodium oxide. Okay. A popular wrong answer is going to be 4. Why is that wrong? Because that's the number of sodiums in 2 molecules. Okay, so be careful there. Number 2. Choose the correct answer from each drop-down about the following chemical reaction. Okay, so it's a printout, so you don't really have the ability to activate the drop-downs, but we can make this work. It's the same equation. 2 sodiums plus 2 molecules of oxygen gas produce 2 molecules of sodium oxide. Okay, so sodium reacts with oxygen to produce sodium oxide. And there you go. Boom. You've got 1 and 2 done. Just remember, products, arrow always points to products. So write that down, arrow. So here's the arrow. It is pointing to your product. Sometimes there's more than 1, sometimes there's only 1. Arrow points to products. All right, number 3. The equation for photosynthesis is shown. Which statement about the equation best identifies evidence that mass is conserved during photosynthesis? If mass is conserved, I have the same number and the same type of atoms on both sides, okay? I don't necessarily have the same number of molecules. I have the same number of each type of atom on both sides, okay? So I have 6 carbons and 6 carbons, 6 times 2, 12 oxygens here, and then 1 times 6, another 6 oxygens over here for a total of 18. I have 6 here, 6 times 2, 12 for a total of 18 on the other side. 6 times 2, 12 hydrogens, 12 times a coefficient of 1, 12 times 1, 12 hydrogens on the product side as well. Okay, so one more time, the thing that's important and the thing to keep in mind is I have to have the same number of carbons on both sides, the same number of oxygens on both sides, the same number of hydrogens on both sides. I have to have the same number of atoms. I don't care about the number of molecules because things can rearrange and be in different formulas, and the molecule numbers aren't necessarily the same. That's no big deal. But I have to count individual atoms. All right. The number of molecules in the reactants is equal to the number of molecules in the products. Well, first of all, it's not molecules that I even care about. But even if that were true, which it's not, that does not indicate a conservation of mass, okay? The number of molecules in the reactant is equal to the number of carbon atoms in the product. No, I'm not looking at number of molecules versus carbon. That's ridiculous. Okay, let's keep going. We haven't found one that's a good answer yet. Remember, we're looking for something about the number of atoms on both sides being equal. The number of states of matter in the reactants is equal to the number of states of matter in the products. Basically, that means like if I have a solid and a liquid in the reactants, I have to have a solid and a liquid in the products. No, that is not the case either. Conservation of mass doesn't say anything about whether something has to be solid, liquid, or gas, or whether things at the end have to be in the same state as the reactants. All right, so hopefully it's D. The number of atoms for each element in the reactants is the same as the number of atoms for each element in the products. And lo and behold, that is our answer. number of atoms on both sides must be equal. Number of atoms, not the number of molecules. Okay. A teacher adds a colorless solution of potassium iodide to a colorless solution of lead nitrate in a beaker. A yellow solid is observed in the beaker. Which statement provides the best evidence that a chemical reaction occurred and that the law of conservation of mass was observed? Okay, well, law of conservation of mass again tells us I have to have the same amount of everything that I started with, the same amount of atoms, okay? But we can have individual atoms rearranging to make new chemical substances. It's just I can't have things magically disappear. Okay, the color change that happened spontaneously, the fact that we had colorless plus colorless giving us something yellow, that indicates that a new substance formed. So definitely a new substance formed. And then, but I also want to talk about law of conservation of mass. The solid increase in mass. No, I can't have an increase in mass. And the mass in the beaker did not change. That's probably going to be our answer. Let's check the other ones. Two substances were mixed together and the solid increased the mass. No. Two substances were mixed together and the mass decreased. No. I've got to have the same amount that I started with that I end with, okay? Mass has to be conserved. Number 5, which of the following substances represents an element? Okay, every time you get to a new capital letter, it is a new element. So this one, that's both carbon and oxygen because it's 2 capital letters. Capital A, little g, that is an element symbol, that's silver. Capital H, capital I, that's 2 elements, hydrogen and iodine. Capital C, capital N, again, that is 2 elements. It's got a little negative charge, but that doesn't matter. 2 capital letters, that's 2 separate elements, okay? Capital D, lowercase b, okay, that's going to be a chemical symbol. Capital X, lowercase e, that's going to be another chemical symbol, okay? So we've got Ag is a chemical symbol, Db, and Xe. So that's going to be 2, 5, and 6. And luckily, that's on the same side of the paper, so I don't have to really go look. 1 and 4, nope. 1, 3, and 4. 1, 3, and 4 are your compounds because you're having more than one element bonded together. All right, look at number 6. The names and chemical formulas of 4 substances are shown in the chart. Which substance listed in the chart is made up of the most atoms? Okay. Carbonic acid has 2 hydrogens, 1 carbon, and 3 oxygens for a total of 6 atoms. Nitric acid has 1 hydrogen, 1 nitrogen, and 3 oxygens for a total of 5. Phosphoric acid has 3 hydrogens, 3 hydrogens, 1 phosphorus, and 4 oxygens. 3 plus 1 plus 4 is 8. That might be our winner in a minute. Sulfuric acid has 2 hydrogens, 1 sulfur, and 4 oxygens for a grand total of 7. All right, so which substance listed in the chart is made up of the most atoms? That is going to be phosphoric acid. Okay, because it has 8 atoms. Okay, now, interestingly enough, all of your substances have 3 different elements. This one has hydrogen, carbon, and oxygen. That's 3 different things. This one has hydrogen, nitrogen, and oxygen, 3 different things. Hydrogen, phosphorus, and oxygen, 3 different things. Hydrogen, sulfur, and oxygen. All of them have 3 different elements, but the one with the most atoms is phosphoric acid.